Okay, so for what we have in the case of number 22, we're looking at forming a frequency distribution with 9 classes, and we have for the set of data given, okay, we have a minimum value of 27 and a maximum value of 598. And in terms of how we are going to construct a frequency distribution, now we need for the 9 classes, we need for all the classes to be of the same width. And again, that is going to be the amount of change as you go from one lower class limit to the next, one upper class limit to the next. And again, there is no one data item that can belong in more than one class. Now, for what we have in terms of establishing the class width, okay, you're looking at in the ratio, you're taking the high value and the low values, and you're taking the difference, and we are looking at dividing by the proposed number of classes, which again is going to be at 9, and we have for the difference between the high and the low values, okay, this will be at 571, and as you divide by 9 we come out to 63.4. And even if this had been a whole number in itself, you would still go up to the next whole number. And for this particular problem, we have established that the class width is going to be at 64. And in looking at the classes and the corresponding frequencies, okay, we have again for the minimum value we have at 27, and again we are looking at adding 64 throughout, proceeding from one lower class limit to the next, and the second lower class limit we have at 91. And again, so this signals that the maximum value for the upper class limit is going to be, for the first class, is going to be at 90, and likewise you're going to add 64 at both ends. So we have for the classes at 27 to 90, 91 to 54, and maintaining a width of 64 throughout, and to make sure that we have 9 classes and to make sure that the maximum value of 598 is covered. Okay, this is how the layout is going to be, and again the class width is still at 64. And so for the corresponding frequencies, we have for the first class there are 13, and there are 2 values between 91 and 154 inclusive. However, there are no values between 155 and 218 in the set. Then we have 5 between 219 and 282, only 1 between 283 and 346, and again only 1 in 347 and 410. And just as was the case with the numbers between 155 and 218 inclusive, we have no set values between 411 and 474. And rounding out the rest of the data, we have one data item between 475 and 538 inclusive, and then we have 2 between 539 and 602. And in terms of what we have for the overall sum of the frequencies should be equal to the total number of data items, and so we have for the sum of the frequencies, this will end up at 25.